All right, so today what we're going to be talking about is how to write domain and range, how to look at it and how to write it. So if you would please pause the video if you're watching this and draw this function right here. It's a quartic function, but draw it. So you can pause the video. We're going to talk about domain, and then we're also going to be talking about how to write the range of this function. Now it's going to be very important you understand that it bottoms out right here on the y values where it's at a -3. So that's why I put that right there. Now technically the domain, even though it looks like it is going up forever on both sides, technically it's still going left and it's still going right. So if it's still going all the way to the left, eventually it's going to reach what's called this concept of -infinity to positive infinity. Well, okay, I apologize. It will never reach it because you can never touch infinity. All right, but what do we call that domain if it goes forever left and right? So remember, domain is dealing with your x values, which run left and right. So I'll put a little x. Range deals with the up and the down, specifically your y values. So if I said it goes from -infinity all the way to positive infinity, that means all real numbers. All right, all real numbers. So if you could say like x's are less than infinity and greater than -infinity if you want to put it in an inequality form. In set builder notation, you would say the set of all x values such that x is an element of the real number system. So that cute little E looking thing there, right there, that symbol means the word element. All right. Remember, that vertical line right there means such that. So this is called set builder notation. So I will write set builder. And I won't write the word notation. I'll just put set builder. Another way you could write it in set builder, it's not very common that you see it this way, but sometimes that vertical symbol right there, that vertical line, is referred to as they put a colon in there, and it means the exact same thing. So sometimes it looks like this, sometimes it looks like this, but these mean the same thing. All right, it's just a different notation. So right here, these mean the set of all x values such that x is an element of the real number system, or any number in the real number system, and this means the same thing. So that's set builder notation. Now the last notation we're going to talk about is this thing called interval notation. So I'm going to write interval notation. I'll put it right down here because it's a little bit easier to see. Interval notation, I think, is like the easiest to write. A lot less symbols, makes it very easy. And what did we say the domain was? We said it was from what? -infinity to positive. So we put -infinity to positive infinity. We use a couple of soft brackets. Just remember, these soft brackets mean not equal to. So these are totally not equal to -infinity to positive infinity. But that would be your answer. That's for your answer for your domain in interval notation. So here we have inequality. I'll write the word, if we wanted to write it as an inequality, that's how we would write it, as an inequality. This is how you write it in set builder notation, and this is how you would write it in interval notation. All right, so we're totally done with the domain, totally done with the domain. Now we're going to move on to range, which is dealing with from the bottom going up. Remember, you always interpret domain from left to right, and you always interpret range from bottom going up, because that's how we're going to write it. So let's look here. What's the smallest value for y that we can see? The smallest value is -3. But technically, what's the largest? Well, no matter where it goes, where's it both going? It's going up to infinity. So we would say, hey, it looks like it starts out at a what? A -3, and it's traveling up to infinity. Now, as an inequality, this is how you would write it as an inequality. You would say all of your y values are greater than or equal to -3. That's how you would write it as an inequality. For set builder notation, you would say the set of all y values such that y is greater than or equal to a -3. Now, in function notation, do you guys see right over here it says y equals h of x. So what are all of our y values equal to? This function known as h of x. So you could also write in set builder notation the set of all h of x values such that h of x is greater than or equal to -3. These all mean the exact same thing. If you wanted to, could you replace that line and put a colon right there in its place? Absolutely. I don't like to do that, but sometimes it's a necessary evil. All right. And last but not least, we're going to write this in what's known as interval notation. So in interval notation, we would say that it goes from -3 to infinity. But this is where we have to figure out whether it's going to be a soft bracket or a hard bracket. Because this graph is technically including a -3, I have to make a hard bracket, but it's never going to touch infinity, so that's going to be a soft bracket. So remember that hard bracket means equal to, and the soft bracket means not equal to. All right, so let's take a look at this funky looking function here, okay? This point right here, it's very important that you know it is at a -1, 2, 3, 4, 5, down 1, 2, 3, 4. This is at a -5, and it's at a -5, and it totally has an open circle. So that's open. So when you're drawing this, make sure you put an open circle there. All right? This point right here is at -2, 0. So if you're drawing this, make sure you put a point there at -2, 0. This point right here is included. It's a solid dot. It's at 1, -5. So that's important to know. That's at 1, -5. And it's also very important to know that this graph ends. This graph ends right here at a 3 and a -2. And it's also very important that you know that this graph never ends going to the left and never ends going up. So it is traveling towards -infinity left, and it is traveling towards positive infinity going up. So when you draw this graph, make sure you include all of those elements. Everything else, it doesn't matter if you kind of go a little bit off a little bit. It's okay. It doesn't have to be perfect, but it needs to be looking something like that. Okay, so what we're going to talk about here is we're going to talk about the domain and the range of this guy. All right, so put domain. Not domain, sorry, my bad. And then we'll put range. All right, domain and range. All right, remember, the domain goes from left to right, which is dealing with all of your x values. And once again, range is dealing with, change colors here, up and down. And it's dealing with all of your y values. Now, the domain is a little bit trickier this time, okay? Because as you guys are traveling, look what happens. Let's think about some very important concepts. It's starting from -infinity, then it gets over here to -5, but we have an open circle. Then it travels from -5 all the way over to +3. So we're actually, just so you guys know, we're going to actually start out with interval notation, which is easier to write, I think, in this particular circumstance. So we're coming from where? We're coming from -infinity, and what's our first kind of stopping point along the way? -5. So we're going to put, it goes to -5. But we can't include the -5 because it's an open circle, so we got to put a soft bracket. And then, once again, it starts traveling from -5 all the way to a 3. So once again, it starts from -5 and it goes all the way to a 3. But what do we have to put at the 3? We got to put a hard bracket because it's including the 3. So if there was only a symbol we could use to combine this guy with this guy, and the symbol that we use is a U, which means union. We're combining both of those answers. So this is the interval of x that's being plotted. All right, so now I'm going to write this in set builder notation. So I'm going to say the set of all x values such that all of my x values are less than or equal to a positive 3 except for one number. So all of my values, it goes less than or equal to a positive 3 except for one value of x. X cannot equal one particular number, and that number is this -5. And that's how you write the domain in set builder notation. The set of all x values such that x is less than or equal to 3, because that's as far as it goes. All the values are going less than that, except for one number. You can't plot a -5. So this is called, once again, set builder. Set builder notation, and this is interval notation. All right, now we're going to talk about the range. Okay, so let's take a look at the range here. How low does it go? It goes all the way down to a -5. But wait a second. This is at a -5, but it's not including it. This is at a -5, and it is including it. So am I allowed to include it, or am I not allowed to include it? Well, because it technically is plotted here, you are allowed to include that as part of your range. So I'm going to write this in set builder notation, except I'm going to use h of x. We're going to say h of x. Instead of the letter y, I'm going to use h of x, such that all of my y values are simply greater than or equal to a -5. And that's it. I'm done. So the open circle impacted the domain, but it did not impact the range, because technically there was a point that was plotted there. So why is it greater than or equal to -5? Because that's as low as it goes. And then it goes up here, it stops. But technically, it doesn't stop over here. So that's why it goes basically from -5 all the way up to positive infinity. In interval notation, I think it's actually even easier to write. In interval notation, we just say it starts where? At -5. And where is it traveling? It travels up and up and up and up forever to infinity. If you don't know the reference to that movie, then you have not lived a very good childhood. But that's okay. Forever. It's from The Sandlot, if you haven't seen it. Okay, so there we go. There's interval notation for both of them. Remember, this is the range. This is the domain. Now, something that you need to be aware of that maybe you haven't seen in a while, but maybe you just kind of need a quick little refresher. All right, so you need to understand looking at a table and looking at a map. All right, so we're going to make a quick little table and a quick little map, and we'll call it a day. And then hopefully when you take your quiz, you will be like, I got this. All right, now I'm going to do a better job at the map here. I'm going to try to do something that's kind of cool. Here we go. Yeah, let's make it all nice and neat, huh? Kind of nice and neat. There we go. Just remember, in a map, these are x's, these are y's. This is your x, this is your y, this is dealing with your domain. Remember, in a map, these are your domain, and this is your range. Now, in a table, you really have to be specific. Like, you got to say 1 goes with a number. I'll say 1 goes with -3, 2 goes with 4, 3 goes with 6, and 4 goes with we'll say -4. Okay? But in a map, I'm just going to put -3. I'll put, you know what? I'll put -4, -3, 4, and a 6. But for my x values, I'm going to do 1, 2, 3, 4. So here, it's pretty easy. You know, what's your domain? 1, 2, 3, 4. What's your range? -4, -3, 4, and 6. But when you're doing a map, you have to understand that 1 goes with -3. 2 goes with 4. 3 goes with 6. And 4 goes with -4. But if they said, hey, what's the domain? What would you write? You write the set of numbers 1, 2, 3, 4. If they asked you for the range, you would say -4, -3, 4, and 6. And so there's the domain and the range. By the way, if there's multiple numbers here that are the same number, you don't have to list them again. So if I made these two -4s right here, then I would just list one -4 and not two -4s. So you only have to list the number once in the range, okay, or the domain. You only have to list the number one time. You don't have to list it multiple times if you see it multiple times. Now this is actually a function because each x value has a y value, but some just because it may not be a function doesn't mean it doesn't have a domain and range, okay? Any set of ordered pairs has a domain and a range no matter what the relation. And that's it. All you guys got to make sure you guys know is the difference between domain and range and how to interpret it in interval notation and set builder notation, whether it's something funky that looks like this or something a little bit less funky that looks like this. Good luck.